Now, again, pretend that these are numbers, because they are. We just don't know what they are yet. Okay? What do we do with price and quantity? We multiply them together, and that tells us how much was spent for that item, doesn't it? So if I've got 3 of these things and I multiply it times 5, how many of these things do I have now? 5 times 3, 15 of those x's, don't I? And if I had one of these x's and I multiply it by 12, now I have 12 of those x's. Okay? So here's how much I spent on mugs. Here's how much I spent on t-shirts. What do I do with those 2 numbers to get total sales? You may be saying it, and I'm just not hearing it because that family. We add them together, don't we? Okay. So we take this top number, add the middle number, and it equals the bottom. Okay? And that's our equation to solve. 15x plus 12x equals 378. Now for some people, depending on your background, some people will figure this out and say, oh, that's easy. I can figure that out and I can write that equation, but now I don't know what to do. Other people will be just the opposite. They'll say, oh, if you would just give me that, I'd be home free. But I'm having trouble figuring out how to get from the word problem to that. Okay? So whichever is harder for you, that's what you need to spend your time working on. Okay? So let's solve this equation. First of all, we've got 15 of these things plus 12 of these same things. How many is that? That's 15 plus 12 of those things, isn't it? And you can use your calculator if you need to. That's 27 of those things, isn't it? So 27 of those things is 378. And we're getting real close. We don't want to know what 27 of those things is. We want to know what one of those things is. What's this 27 doing to that x? It's multiplying it. What's the opposite of that? Divide. So if we'll divide this thing by 27, oops, but we have to divide the other thing by 27, they won't be equal to each other, will they? So 27 divided by 27 is what? It's 1. And 1 times anything just gives you the anything, doesn't it? So effectively, those 27s go away, don't they? They don't affect the answer anymore. So we have 378 divided by 27. And you can use your calculator for, does that look like 14? So x is 14. By the way, if you work one of these invoice problems and you don't get a whole number, start over. It is wrong. We can't have 14.3 t-shirts that we sold. Okay, it's either 14 or it's 15. We're not going to sell a piece of a t-shirt. Yes.
Is there a set rule that lets you know which one X is? Because I thought I read something on one of these, let X be the higher priced item. So how will you know what to choose?
That's an excellent question. We're going to look at the other situation where we do it that way in just a minute. Okay. Whenever they say, oh, are we done? We're almost done. They asked us how many mugs did they sell and how many t-shirts did they sell. This is X, which we let be the t-shirts. So we just found out that we sold 14 t-shirts, but we haven't said how many mugs we sold yet. Haven't. So we're not quite done. X is 14 t-shirts, and we know that mugs is 3 times that, and we just found out what that was, 14. So now we can multiply 3 times 14, and that's how many mugs we sold. So we really have 2 answers, don't we? And we sold 14 t-shirts and 42 mugs. Daryl's asked a good question. How do we know what to let X equals? Well, there's 2 different situations. Situation 1 is where they tell us one of them sold more than the other. We could have let the bigger one equal X, but then we would have had to make the little one 1/3 X, wouldn't we? If this is 3 times as big as that. I don't know about you, but I'd much rather work with whole numbers than with fractions. Okay? You can do it this way, but you're being masochistic if you do. So, when they tell us one who sold more than the other, we let X be the smaller quantity, and whatever times X that is, we let be the larger quantity. Here they told us which one was bigger. Okay? Now we're going to do it the other way, where we don't know which one's bigger. First of all, any questions about this so far? All right, now, the nice thing about invoice problems is we can check our answer. Anytime we solve an equation, we can always check our answer. But in this case, we can more easily check our answer because there's a whole lot of numbers where one of them is 3 times as big as the other, aren't there? 10 and 30, 1 and 3, 3 and 36. How do we know that these are the right ones? Well, let's put them in here. If t-shirts sell for $5 and we bought 14 of them, how much did we spend on t-shirts? 14 times 5, didn't we? So how much money did we spend on t-shirts? $70? And if we spent $42, no.
You got that backwards, don't
Do I have it backwards?
you? 42 bucks or $5.
Oh, yeah, thank you. Yes, my bad. Thank you. T-shirts are $12. As I was looking at that, I was saying, this isn't going to work out right. Okay, what's 14 times $12? 140 plus 24? 28? 168? Does that sound right? Somebody punch it.
Yeah,
Joyce said
168.
168. So we spent 168 on t-shirts. I'm doing something that I tell students not to do. You should never write small. I'm doing it to try to keep it on the camera. Paper is cheap. Use lots of it. And write big enough so you can read your own writing. I can't tell you how many students I've seen miss points on a test. They had the right answer. They had the right numbers there, but they wrote it so small that they misread their own writing. So, write big enough where you can see it. So we got $168 for the t-shirt. In other words, if we put 14 here, 12 times 14 is 168. How many mugs did we sell? 42 times 5 is 210. And is 210 plus 168 378? It is. So we can know we got it right, okay, because we can check it. All right, now let's answer Darvis's question. If you flip the page and look at